Hello, students. Welcome to this lecture on statistics. In this lecture, we will cover NCERT section 13.1 to 13.4. So let's get started. This is disclaimer. So we will start with an introduction to the topic statistics. So we here understand how data is collected, analyzed, and interpreted. Statistics is a crucial topic because it helps us make informed decisions based on data. Then we will discuss measures of dispersion. Next, we will discuss the range. So there we will discuss what is range, okay, what is the definition of range, and what is the importance of range. Finally, we will discuss mean deviation. Okay, there we will discuss mean deviation definition and formula, how to find mean deviation. Okay, I hope you are ready to start. So let's get started. Let's see. Introduction of this chapter. Okay, statistics deals with data collected for specific purposes through methods like surveys, experiments, and observations. Okay, so statistics is all about dealing with data that we collect for specific purposes. Okay, it may be survey, experiment, or observations. Okay, now let's talk about what we do with the data. Okay, so we can make decisions by analyzing and interpreting data. Okay, next we can represent data using graphs and tables. These visual tools help us see patterns and trends more clearly. And we also find a central value like the mean, median, mode, which shows us where the data is centered. Let's introduce the concept of dispersion. So, what is dispersion? So, dispersion refers to how spread out the data is. Okay, so this scatter or spread is called dispersion. Okay, so it tells us about the variability in our data. So, for example, if test scores are all close together, then the dispersion is low. Finally, to compare different data distributions meaningfully, we need to understand, we need to measure their dispersion. Okay, so this helps us understand how similar or different the data sets are. Okay, by comparing dispersion, we can make more accurate conclusions about the data. Now, we will discuss about central tendency. Okay, so we will now talk about central tendency. Okay, so central tendency is a key concept in statistics that helps us identify the center or typical value of a data set. It helps us understand where most of the data points are located. Okay, giving us a clearer picture of the data's overall distribution. Now, we will look at the different types of central tendency. Okay, so there are some types of central tendency. Now we will discuss about them. the first type of central tendency is the mean. The next type is median. And the third type is mode. Okay, so later we will discuss more about mean, median, and mode. Now, we will discuss different types of central tendency. First one is mean. So let's begin with the mean. So what is mean? So mean is one of the most common measures of central tendency. The mean is simply the average of all the numbers in a data set. Okay, so if we calculate average of all the numbers in the data set, then that is actually mean of the data. So the formula for mean is basically x bar equal to 1 by n summation I equal to 1 to n xi. Okay, so x bar here is basically mean. Okay, and xi is the data point and n is the total number of data. To make this concept clearer, let's look at an example. So in this example, we consider the runs scored by batsmen in their last 10 matches as follows. Okay, so here you can see run scores of batsman A. Okay, in their last 10 matches 30, 91, 0, 64, 42, 80, 35, 117, 71. And here we have to find the mean of the score. How can we find mean of the given score for batsman A? So for that, we will use mean formula. So mean of the data is given by x bar equal to 1 by n summation I equal to 1 to n xi. Here, the value of n is 10 and xi is 30, 91, 0, 64, 42, 80, 35, 117 and 71. So mean x bar equal to 1 by 10 summation I equal to 1 to 10 xi. Okay, and if we take sum of the given data xi, then you will get that is equal to 530. Okay, so mean x bar, this is equal to 530 upon 10, and after simplifying you will get finally this is equal to 53. So mean x bar equal to 53. Now we will tell about another types of central tendency. So here we will basically discuss about median. Okay, so median is the second type of central tendency. So what is median? Median is the middle value when all the numbers are arranged in ascending order, smallest to largest, or descending means largest to smallest order. Okay, where where the formula, okay, formula for median is median equal to n plus 1 by 2th observation, where n is the total number of observation. Okay, so if there is odd number of values, then median equal to n plus 1 by 2th observation, and here n is the total number of observation. If there is an even number of values, then the median is the average of two middle numbers. Okay, so when n is an even number, okay, then median is nothing but average of two middle numbers. Okay, so median this is equal to n by 2th observation plus n by 2 plus 1th observation upon 2, where n is the total number of observation. Let us take an example. So in this example, we consider the runs scored by batsmen in their last 10 matches as follows. For batsman A, 30, 91, 0, 64, 42, 80, 30, 5, 117, 71. And then we have to find the median of the score. So our goal is to determine the median score from the given data. So let's solve this example. So first we need to arrange the score. Okay, so this is a crucial step because the median is the middle value in an ordered data set. So we need to sort the scores either in ascending order or descending order. Okay, so first of all, we need to arrange the score in ascending or descending order. Now, we will sort the score in ascending order. So the score will be 0, 5, 30, 30, 42, 64, 71, 80, 91, 117. Okay. Since n equal to 10 and 10 is even number, so n is an even number. So the formula for finding the median is an even set is basically median is equal to n by 2th observation plus n by 2 plus 1th observation upon 2. Okay, that means the average of two middle terms is basically the median. And here n equal to 10. So median, this is equal to fifth observation plus 6th observation upon 2. Okay, and here 5th observation is 42 and 6th observation is 64. So 42 plus 64 upon 2, this is equal to 53. Therefore, median of the score is 53. So I hope this example is clear to all of you. So now let's move to the next one. Now, in this example, we consider the runs scored by the batsman in the last 9 matches as follows. For batsman C, 53, 46, 48, 50, 53, 53, 58, 60, 75. And here we have to find the median of the score. Let's solve this example step by step. First, we need to arrange the scores 53, 46, 48, 50, 53, 53, 58, 60, 75 in order. Okay, this step is an important step because the median is the middle value of an ordered dataset. Now, we will sort the score in ascending order. That means smallest to largest. So the score will be 46, 48, 50, 58, 3, 53, 53. Okay, 3 times 53, then 58, then 60, then 75. Since n equal to 9, which is odd number. So the formula for the finding the median when n is odd is basically median is equal to n plus 1 by 2th observation. Okay, and here easily you can see the value of n is 9. Okay, so put here the value of n equal to 9 in this formula and then you will get the median. So median, this is equal to 5th observation, and in ascending order the data will be 46, 48, 50, 53, 53, 53, 58, 60, 75. Okay. And here, fifth observation is 53. So median is 53. Therefore, median of the score is 53. I hope it's clear to all of you. Now, we will discuss another types of central tendency, that is mode. Okay, so mode is a key measure of central tendency. So what is mode? So mode is the number that appears most often in the dataset. Okay, so there can be more than one mode if multiple numbers occur with the same highest frequency. So mode of the dataset is not unique. Okay, it may be one or more than one. Let's look at an example to better understand the concept of mode. Okay, so we consider the runs scored by batsmen in their last 10 matches as follows. For batsman B, the data are 53, 46, 48, 50, 53, 53, 58, 60, 57, 52. Okay, so here we have to find mod of the given score. So let's solve this example. So to calculate the mod, we need to find the score which occur most often in the dataset. So let's try to find which number most occur in the given dataset. Since 53 appears 3 times in the dataset. Okay, so 53 is occurring most often in the dataset. So what will be the mod of this dataset? So therefore, mod of the score is 53. I hope this example is clear to your concept on mod. Now, we will discuss measures of variability. Okay, so we will discuss why understanding variability is crucial when analyzing datasets. So let's start by looking at the runs scored by batsman A in a series of matches. Okay, that are 30, 91, 0, 64, 42, 80, 30, 5, 117, 71. Okay, so we find that mean and median of the runs scored by the batsman A is 53. Also, mean and median of the runs scored by the batsman B is same as A, that is 53 also. So now this raises an important question, that is, can we say that performance of two players is same? Okay, so because their mean and median scores are identical, so can we say that the performance of the two players is same? So let's think about what other factors might be at play. So clearly the answer is no. The variability in batsman A scores ranges from a minimum of 0 to a maximum of 170. This wide range indicates a lot of fluctuation in performance. Okay. So in contrast, batsman B scores range from 46 to 60, showing much less variability. Okay. So this narrower range suggests more consistent performance. Here you can see here in this diagram, okay, figure. So where the range of the runs scored by batsman is from 46 to 60. And this shows that just looking at the average and median doesn't give us the full picture of the data. Okay. And we need for measures of variability. So, variability is another factor which is required to be studied under statistics. Okay, so that is why we need variability in statistics. Now, we will discuss about dispersion. Okay, so dispersion is a key concept that helps us understand how data points are spread out in a dataset. Let's start by defining dispersion. So dispersion shows how spread out numbers are from their average value. Next, we see that dispersion tells us whether values are closer together or far apart in a dataset. Now, let's look at the key measures of dispersion. The first measure of dispersion is the range. Next, we have the quartile deviation, also known as the interquartile range. Then, the mean deviation is another measure of dispersion. Finally, we have the standard deviation. So, these are key measures of dispersion. First, we will discuss range. Okay, so range is an important measure of dispersion. Okay, that helps us understand the spread of data in a dataset. So we will start by defining what range means and then look at how to calculate it. So let's begin by defining the range. The range is the difference between the maximum and minimum values in a dataset. Okay, this simple calculation gives us a quick sense of how spread out the data is. Now, let's look at the formula for calculating the range. It's straightforward. Range equal to max value minus mean value. Next, we will discuss some properties of the range. Notice how the simplicity of calculating the range makes. Okay, so easy to calculate and understand. And however, the range has its limitations. Okay, so range can be calculated easily. Okay, and we can easily understand range of any data set, but there are some limitation of range. Okay, so it's based on only two extreme values, which makes it very sensitive to outliers. Okay, outliers are extreme values that can skew the range significantly. So it is based on only two extreme values and is very sensitive to outliers. Okay, extreme values. And another limitation is it does not give any information about the spread of data between these extremes. Okay, so these are some limitations of range. So we will look at an example involving the scores of a team to understand how to calculate the range. Okay, so given the scores of team A 38, 47, 40, 35, and 42. And our goal is to find the range of the scores of team A. So let's solve this example step by step. To begin calculating the range, we first need to identify the maximum and minimum values in our dataset. In our example, maximum value is 47 and the minimum value is 35. And we know that the formula for calculating the range is max value minus mean value. Okay, so we have range equal to maximum value in the dataset minus minimum value in the dataset. So it implies range equal to 47 minus 35. And finally, we find the range of the given scores is 12. Okay. Now, we will discuss mean deviation. Okay, so what is mean deviation? So, mean deviation is a measure that helps us understand how spread out our data is around a central value. Okay, so we will now discuss how it differs from other measures of speed and why it's useful. Okay, so let's start by defining deviation. So the deviation of an observation from a central value A is x minus A. So this tells us how far each data point is from our chosen central value. Now let's talk about mean deviation. Okay, so this is the arithmetic mean of the absolute deviations of the observations from a central tendency measures such as the mean, median, and mode. Mean deviations improves upon the range by considering the deviation of every observation from the center. Okay, unlike the range which only looks at the extremes. Okay, mean deviation gives us a more comprehensive view by including all data points. However, it's important to note that some deviations are positive and some are negative. So they might cancel each other out. Okay, so now let's note down a statement. Okay, the sum of deviations from the mean is always 0. Now let's prove it. So let's say we have observations x1, x2 up to xn. We know that mean x bar equal to 1 by n sum from 1 by I equal to 1 to n xi. Now deviations from the mean are xi minus x bar. Now sum of deviations from mean are summation I equal to 1 to n xi minus x bar. This is equal to summation I equal to 1 to n xi minus summation I equal to 1 to n x bar. And it implies summation I equal to 1 to n xi minus x bar. This is equal to summation xi minus n times x bar. And it implies summation I equal to 1 to n xi minus x bar. This is equal to summation I equal to 1 to n xi minus n times summation I equal to 1 to n xi upon n. And since x bar equal to summation I equal to 1 to n xi upon n. And it implies summation I equal to 1 to n xi minus x bar equal to summation I equal to 1 to n xi minus summation I equal to 1 to n xi. Okay, and here each terms will be cancelled out and we will get this is equal to 0. Also, mean of deviations. This is equal to sum of deviations upon number of observations. Sum of deviations is always 0. So 0 upon n. This is equal to 0. Mean of deviations is 0. Now, take a note on remark. Okay, so mean deviation can obtain from any measure of central tendency. Okay, note this point. Now, let's look at an question. Okay, so in this question, we have to find the mean of the following data set: 15, 28, 42, 35, 15, 50, 28, 63, 15, 42. Okay. So let's start by looking at the question. So we need to find the mean of the following data set. Okay. So let's solve this question step by step. We will know the formula for mean. The mean of the data is given by x bar equal to 1 by n summation I equal to 1 to n xi. Here, n equal to 10, xi are 15, 28, 42, 35, 15, 50, 28, 63, 15, and 42. So, mean x bar equal to 1 by 10 summation I equal to 1 to 10 xi. Okay, and if we add x1, x2 up to xn, then you will get, okay, if we add x1 plus x2 plus x3 plus dot dot x10, then you will get 333. Okay, so mean x bar equal to 1 by 10 times 333, and this is equal to simply 33.3. Therefore, mean of the dataset is 33.3. Now, in this question, we have to find the median of the following numbers: 15, 8, 22, 13, 7. Find the median of the following numbers. So first, we need to arrange the numbers in either ascending order or descending order. Okay, so first we need to arrange the number 15, 8, 22, 13, 7 in either ascending or descending order. Now, we will sort the number in ascending order. So the number will be 7, 8, 13, 15, 22. Since n equal to 5 and 5 is odd, so median is equal to n plus 1 by 2th observation. And here n equal to 5. So median is 5 plus 1 by 2th observation, that is third observation. Okay. And in the arranged data set, the third observation is 13. So median is 13. Therefore, median of the number is 13. Now, in this question, we have to find the median of the following numbers. Okay, 12, 5, 16, 8, 9, 14. So let's solve this question step by step. First, we need to arrange the number 12, 5, 16, 8, 9, 14 in either ascending or descending order. Now, we will sort the number in ascending order. So the number will be 5, 8, 9, 12, 14, 16. Since n equal to 6, which is even, so it implies median is equal to n by 2th observation plus n by 2 plus 1th observation upon 2. Here n is 6, so median is third observation plus fourth observation upon 2. And here third observation is 9 and fourth observation is 12. So median is 9 plus 12 upon 2. So median is 21 upon 2. This is equal to 10.5. Therefore, median of the number is 10.5. Now, let's consider the marks obtained by a student in their 12 monthly test. Okay, so the marks are as follows: 85, 92, 88, 95, 88, 85, 90, 85, 87, 91, 89, 85, 88, 92. And here we have to find mod of the number. So let's solve this question step by step. So to calculate the mod, we need to find the marks that occur most often in the dataset. So first of all, try to find the marks that occur most often in the dataset. So we have in the dataset 85, 92, 88, 85, 90, 85, 87, 91, 89, 85, 88, 92. Okay. So now count which number occur most often. 85 occurs 4 times. 92 appears 2 times. 88 appears 2 times. So all other numbers appear only once. So which number occurs most often in the dataset? Here 85 occurs most often in the dataset. So since 85 occurs most frequently, that is 4 times, therefore the mod of the dataset is 85. I hope this question is clear to all of you. Now, in this question, we have to find the range of the heights in centimeter of students in a class. Okay, so the data given in the question are 165, 158, 172, 160, 169, and we have to find here the range of the heights. So let's solve this question step by step. To calculate the range, first we need to identify maximum and minimum value in the dataset. So in the dataset, maximum value is 172 and minimum value is 158. So we know the formula to find range, maximum value minus minimum value in the dataset. So now it implies range is equal to 172 minus 158. This is equal to 14. Therefore, range of the given heights is 14 centimeter. I hope this question is clear to all of you. So students, that's all for today's lecture, and thank you very much to all of you.